How is everybody today? Yeah? So today I'm going to talk to you about architecture. How many of you attended the last MEC? Okay, a good number of you. Well, thankfully, I am going to deliver a different presentation. But we'll start off with some fundamentals, because I want to just re-highlight some of the key architectural changes we made into the product. And then we're going to shift gears a little bit and talk about client connectivity. And then we'll move along into some planning principles, specifically around namespace and load balancing, as they're rather key in this new architecture that we have. And then we're going to end with an area that I feel is about time that we discuss, which is how we think you should deploy your on-premises Exchange environment. I'm standing too far away from the console. Okay, everyone should be familiar with this slide, so I'm not going to spend entirely a lot of time on it. The key thing is that we've radically changed the way Exchange server role architecture looks when compared to the prior releases. Whereas before we had 5 server roles, we now have 3 server roles. We have the reincarnated Edge Transport server role, we have the client access server role, and we have the mailbox server role. The client access server role is vastly different than in prior releases in that it no longer has any sort of data processing component to it. It's strictly a network interface type of server role. And then we have the mailbox server role, which is primarily responsible for data storage, but now also responsible for data processing. The key concept with our Exchange 2013 server role architecture is this notion of every server is an island. You can basically take a server and break it down into its core components. We have, if you look at it from an OSI layer model, we have up at layer 7, the application stack. And then we have the business logic layer, where all the data rendering, transcoding, and the like occur. And then we have the storage layer. The problem in prior releases, which is why the 3 core server roles were tightly coupled, mailbox, hub transport, and client access, was that these components were interdispersed across all of these server roles. So when we had a message come in, it would come into a hub transport server role, and then that hub transport server role within that Active Directory site could interface directly through store driver to deliver a message. Now this could occur from server 1 to server 2. Server 2 could be involved, or server 2 could be the one that's injecting a message into a hub transport server interface on server 1. And this is why we had a strict major version boundary, because of the RPC interfaces and everything else that was tightly coupled along this communication pathway. We never guaranteed that once a message came into the transport stack, that would flow all the way down to the storage stack within that server role. Whereas in Exchange 2013, we have done just that. We now enforce communication at the protocol layer and drive down the stack on the actual server, preventing the communication pathways through the different layers of the server role. What this essentially means is that for any given user's session, that session is going to be serviced by the protocol that is local to the active database copy. Only that protocol that is on the same server as that active database copy will be the one responsible for doing any data processing, any data rendering, any content conversion of that data. This gets us away from having to worry about version boundaries. We're now uncoupled along that dimension. It always ensures that, and it also, from a connectivity standpoint, always ensures that all of the connections always end up at the same place, the mailbox server hosting the active copy. We've removed session affinity as a boundary in that regard. So what is the CAS role now in Exchange 2013? As I mentioned, it's evolved significantly. It's not the client access server role you grew up with. It is now only doing 2 key things. It authenticates you and it makes an intelligent decision on where to route the request. Through that, it has 3 key components. We have the HTTP proxy component and other client protocol proxy components for like IMAP and POP. We have a unified messaging call router, and then we have an SMTP proxy component, which we refer to as the front-end transport service. But other than that, that's all CAS does. It does no data storage, no data rendering, no data processing. It simply makes a decision. Where is your mailbox located, and how is the best path that I can take to get that connection to the mailbox server? In other words, an intelligent proxy. The mailbox server role has evolved in this release as well. Instead of just being the storage repository, it now also houses all the components that do that data processing, data rendering, and content conversion. And it has changed in that end users no longer connect directly to the mailbox server. All end user connectivity is through the client access server role. The mailbox servers are still what we drive together to form a collective unit known as a database availability group to provide us that high availability and site resilient solution. The DAG is still our replication boundary in Exchange 2013, and we can still have as up to 16 mailbox servers within a DAG, each mailbox server hosting 100 database copies, with the active database copies dispersed across all the mailbox servers within that DAG if need be. I don't think I've ever done a session where I don't talk about I/O. So, in Exchange 2003, we were a very I/O-driven application. We were the canary in the coal mine that determined whether your storage was performing or not performing. Generally, we found that it wasn't performing well. We've done a lot of work over the years to make it so that we're no longer focused on I/O, but we're focused on capacity. And so, with Exchange 2013, we have a 93% reduction in I/O when you compare that same mailbox that was on Exchange 2003. That 1.0 mailbox is now 0.07 I/Os on Exchange 2013. Huge win there. But there's a lot more to it than that. Like I said, we want to get away from being focused on I/O. We want to be more focused on capacity. And why is that? Well, when you look at where the market is trending, our large capacity format disks, we have 4 terabytes on the market today. By the end of next year, we will have 12 terabyte disks on the market. Capacity is where it's moving, not I/O. We are bound by our I/O, but we're not bound by capacity. We can fit more and more capacity on a platter as time progresses. So we need to be more efficient in capacity. And I know what a lot of you think. You think this is one of those wonderful marketing slides. And we know how marketing does sleight of hand. So I thought it would be better to show you what we've done to actually achieve that I/O reduction. It started back with the release of Exchange 2007, which began development back in the early days of 2005. We moved to the 64-bit architecture. We introduced support for 2 to the 31st generations of log files. We introduced continuous replication, lost log resilience, standby continuous replication. We removed partial merges. We removed page dependencies. We introduced the concept of parallel mounting, and so forth. All of that work to help us drive to the notion of 1 gigabyte mailboxes and 20,000 items per folder. But we didn't stop there. Exchange 2010. We made significant changes to our page size. We dramatically changed our storage schema, moving to a more contiguous layout of how we lay pages in the database file, moving away from random locations of data, per mailbox tables from a logical perspective, deferring our lazy view updates over time, smoothing out our I/O writes so that we're less bursty and having more of a quality of service around how we write our I/Os. Optimizing for 7200 RPM disks, for those large capacity, slow performing disks. Also that we could have a design model that such that you could deploy a single database on a JBOD disk that is replicated with multiple copies and have a large mailbox with 100,000 items per folder. But that wasn't the end. We still are innovating. Exchange 2013 completely replaced the store process, removed one of the failure modes that we had, and now we have per process support for each database. We've introduced lazy indexes. We moved away from storing properties in the storage engine from a per column process to storing this data in a blob structure. Improving our support, further driving down our I/O, making our passive I/O as similar as we can to our active I/O so that we can support multiple databases per disk. And improving other technologies like introducing auto reseed, moving away from a defined store maintenance, moving to a time-based assistance schedule. Also that we can get to a model where we can support 100 gig mailboxes and 1 million items per folder. To get to a capacity-driven model. The days of needing a 10,000 RPM disk are gone. The days of needing a 15,000 RPM disks are gone. And you certainly don't need solid-state drives to operate Exchange. The Edge Transport role, switching gears. Reincarnated in SP1. How many of you use the Edge Transport role? Okay, so maybe 20 of you. Well, we did it for you guys. The Edge Transport role really hasn't changed much from its predecessors. It's still a server role you deploy in the perimeter network that can queue its data and act as an interface between your internet-based mail flow and your internal organization. It has changed, though, slightly in that it is a command line only driven appliance now. And that was a tactical decision we made because of the fact that in the rest of the product, we moved to the Exchange Admin Center for management of your infrastructure, which is an IIS-based application. We figured we should reduce the attack surface area on the Edge Transport server role, and that's why we didn't ship the Exchange Admin Center on it, so that there is no IIS stack included with the Edge Transport. It also no longer has a built-in antivirus component, but it does ship with all the anti-spam components that you know, connection filtering, IP block lists and allow lists, recipient filtering, and the like, and the smart screen technology that we've known and utilized since Exchange 2003 and iterated on. And again, we still leverage the Edge synchronization process to provide a one-way synchronization of hash configuration and replication data to the Edge Transport server role, so that we have a secure instance on that edge and not have to worry about the interaction between Edge and your internal network. One key difference that I will call out between what you might expect and how it actually operates is that Edge Sync is through the mailbox server role on Exchange 2013. And yes, you can have legacy Hub Transport servers act on behalf and do Edge Sync with an Exchange 2013 Edge Transport server. The client access server role, more specifically the front-end transport service, is only involved if you co-locate the mailbox server and the client access server role in this case. But speaking of transport, probably goes without saying that we should kind of walk through what the new architecture looks like with transport. Because in prior releases, we had the Edge Transport server role, and then we had the Hub Transport server role. And the Hub Transport server role was obviously there to deal with all routing of mail flow and all policy enforcement. Well, we've broken the Hub Transport role up into multiple different components within Exchange 2013. For the first time, we've introduced the notion of a load balance SMTP component, which is known as the front-end transport service on the client access server role. It is a stateless component that simply, like the client protocols on CAS, is an intelligent proxy to route the SMTP request to a mailbox server that can actually do all the processing for it. And then we have the transport service on the mailbox server role. The transport service is very similar to the hub transport server role in that it does all of the routing decisions and policy enforcement. But what it no longer has is store driver. Store driver has been removed and moved into the mailbox transport component. Mailbox transport is comprised of two services, the mailbox transport delivery and the mailbox transport submission. The mailbox transport component is how we enact on the every server is an island principle, maintaining that boundary to ensure that we are driving down the stack as across to all over the stack. So let's say I have a message, and it's coming in from, it could be from the internet, it could be coming from a SharePoint entity, it could be coming from an IMAP or a POP client. In those scenarios, we'll probably engage the FET component on CAS. So we'll hit the load balancer through smtp.contosa.com, and we'll be assigned to one of the two CAS machines. In this case, we proxy to the second CAS in our infrastructure. CAS is going to do a very minute enumeration of that recipient list. There is no categorizer on the front-end transport server role. It will simply look at the recipients, determine how many recipients there are, and then make a decision as to what the best mailbox server it should route the request to. And in the case of Exchange 2013, one of the new routing boundaries is the DAG. So we will prefer to route this to a DAG member that hosts one or more of the recipients in this particular message. Now, in our case, our recipients reside in the same DAG. So it's just a question of which of these two servers do we route this do we actually facilitate the proxy of this connection to? We have a 50% chance here. It's either going to go to mailbox server 1 or mailbox server 2. In this case, we route the request to mailbox server 1. This is where we'll queue the message. We'll also do our categorization of the message. And we'll, in this case, because we're at our final destination, we will bifurcate the message. Now, in past releases, the transport service could have interfaced directly with the store on server 2 to deliver that message. But that's no longer the case in Exchange 2013. We have to follow the every server is an island principle. So, instead of interfacing with store, we interface with the mailbox transport delivery service on the servers hosting the active database copy for our recipients. So in this case, we will bifurcate. We'll hand that off to mailbox transport, which, like the front-end transport, is stateless. It will do a content conversion of that message via local RPC, deliver that message into the store for that particular mailbox. Now, it goes without saying that there are some potential issues with the transport architecture. For the past two releases, we've shipped transport with a single point of failure because we only store the data in one location. You know, you have the queue, the primary copy, the queue, and then once the message was delivered, it was stored in the affectionately termed transport dumpster. But that transport dumpster was located in the same site as where the active database copy is, generally. So if we lose that data center that hosts that copy, not only do we lose the database copy and potentially the transaction logs that hold that message, but we also lost our recovery mechanism. And we wouldn't be able to recover that up until we actually restored connectivity to that particular data center. So that is one single point of failure. Exchange 2013, its new architecture, actually introduced another single point of failure. Because this notion of we're delivering to a transport service, and we queue at the transport service, like in our previous example on mailbox server 1, and then the active database copy for one of those recipients is also on mailbox server 1, then the copy that we're retaining for recovery purposes is on mailbox server 1, because that's where the queue is, and our active copy is there. So if we lost mailbox server 1 before any data replicated off, we have another single point of failure. So those two things, those two issues we wanted to solve in Exchange 2013. And what better way to solve it than to leverage the DAG? The DAG is our unit of of high availability. It's our replication boundary. So it only makes sense that if we want to preserve transport and protect transport from failure, that we would want to replicate transport within the DAG. The way we do this replication is through an infrastructure that we introduced in Exchange 2010, known as shadow redundancy, where we will make another copy of that message prior to acknowledging receipt of the message. And in this case, in Exchange 2013, we make that copy on another server within the DAG, giving preference to a server in another Active Directory site, thereby obtaining transport site resilience. We also made some other improvements in this area. In past releases, you'd have your primary queue, you'd have your shadow queue, and you'd have your transport dumpster. 3 different locations for storage, for storing your transport data. That's both capacity inefficient and I/O inefficient. So in Exchange 2013, we use the same queue for whether it's a shadow copy or we're retaining it for longevity for recovery in the event of a lossy failure, what we now refer to as safety net. Safety net is now simply a time-based preservation of data, whereas in the past we could do things based on the replication feedback loop. We now want to retain that data for a set period of time, by default 2 days, and we recommend that you configure your safety net threshold to be equal to your replay lag time if you deploy a lag database copy. With all that, though, there comes the notion of how do we ensure that the server is operating not only correctly, but efficiently. You know, the idea of looking at just whether the health of a protocol or the health of the database, is the database up, is the protocol up, is not the right approach. We need to focus more on the end user, looking at things like the availability, the latency, and whether there are any errors. You know, can I get to the door? Can I unlock the door? And is there a brick wall once I open the door? That type of scenario. We want to be very focused on that. But to be focused on that, we can't just measure the data. We actually have to act on the data. And this is where managed availability comes into play. Managed availability is a new infrastructure that is on every Exchange 2013 server that you deploy, that sits there, collects data through a probe engine. That data is then evaluated by a monitoring engine to determine whether the particular protocol, service, component is either healthy or unhealthy. And if the monitoring engine decides based on that measured data that the component or protocol is unhealthy, it then initiates a series of recovery actions based on a time-based sequence of events to bring that particular component or protocol back into a healthy state. And in the event that the system cannot get it back to a healthy state, only then will it initiate an escalation to get human involvement by effectively putting a note in the application log, which then the System Center management agent detects, and it bubbles up an alert in SCOM or whatever third-party operations management solution you're deploying. But the whole goal is to get us back to, if a problem arises, we need to ensure that the experience for the end user doesn't get affected. So let's look at the way this is. Let's say I have a user, and my mailbox is on server 1, and I want to utilize OWA. So I'm going to hit the load balancer, get assigned to CAS. CAS is going to proxy me to server 1, since that's where my active database copy is located. Everything's great. But then something happens to OWA. We get the probe, the data that's coming in from the probe tells the monitor that OWA is no longer healthy. That kicks off a name time sequence of events that we will attempt to recover OWA on this particular server. We'll detect that failure. The first thing we'll do, because in all of our learnings of managing Office 365, what we found to be the simplest approach to solving problems with OWA is to recycle the application pool with OWA. So we'll attempt that. If at this point the monitor becomes healthy due to the data that's being collected by the probe, we'll consider that a healthy system again, and everything will continue as it was before. The end user's not impacted at all. He continues to access, his mailbox is still located on server 1, and so forth. But let's say it fails again. We're going to detect that failure. We're going to, once again, initiate the same recovery action. Let's recycle that app pool. Now the key here is, it doesn't really matter if we actually execute the recycle of the app pool or we don't. The key is that after a certain period of time, if the monitor is still unhealthy, we'll initiate the next phase in our recovery sequence. In this case, we're going to get the users off the server. Now, why is that? It goes back to that original concept that I said, the key to enlightenment. For a given user session, the protocol instance that will be involved is going to be the protocol instance that is local to the active database copy. So the OA instance on Mailbox 2, the OA instance on Mailbox 3 will never be involved with servicing a request for the active databases on Mailbox Server 1. Only Mailbox Server 1's OA instance will be involved. Let's think about Outlook connectivity. You know, if I have 3,000 users on Mailbox Server 1 active at any one time, and Outlook and the RPC client access service crashes, that means all 3,000 users are no longer able to connect to Outlook. It's not a good situation, right? So this is why we've built in this infrastructure. So we fail over the database to Mailbox 2. The clients will immediately, CAS will simply proxy the request to Mailbox Server 2, since that's where the database is now activated. User's experience is still not broken. At some later point in time, Mailbox 1 will become healthy again, either through additional steps taken by managed availability, maybe by rebooting the server as an example, or by finally escalating to a human to take a look at this server to figure out why OA keeps crashing on this particular box. But this is the goal of managed availability, to ensure that while things may happen, we want to ensure that the experience is not affected. So let's switch gears and talk about client connectivity. The client protocols. We have a bunch of HTTP-based clients now. We have OA, ActiveSync, PowerShell, the Exchange Admin Center. All of those connect using HTTP. They're going to hit a CAS, be assigned to a CAS, and the CAS is then going to proxy those sessions to the mailbox server hosting the active copy of that database for that given user's request. Likewise, POP clients. They're going to use the POP protocol to hit CAS. CAS is going to utilize the same protocol that the client connected with to proxy to the mailbox server. The key thing here is that we're getting away from very poorly designed protocols that were not designed for WAN type of bandwidth to moving to a client-based protocol that is designed for WAN communication, that is tolerant of high latency and throughput concerns. So utilizing HTTP for the client protocols, utilizing POP and IMAP for the POP and IMAP protocol. If it's an SMTP session, we'll utilize SMTP to the back end. Telephony is the unique one. For SIP and RTP sessions, we actually won't proxy through CAS. The Unified Messaging Call Router will actually issue a redirect to the mailbox server hosting the active copy. We made a substantial change in our architecture with Exchange 2013 in that we removed RPC TCP as a connectivity paradigm with Outlook, moving to only supporting RPC HTTP as a connectivity mechanism, what was or is known as Outlook Anywhere. There were several reasons for this. I mean, you have to think back. CAS 2013 is simply a proxy and authentication server. It just doesn't do any processing of the data. So that's one of the reasons why we did this. We want to utilize the HTTP protocol all the way through. We don't want to leverage RPC. We don't want to do any processing, de-encapsulating the RPC out of the HTTP at the CAS layer, because that means we become constrained again from a geographical perspective. We're then tied to having a set of CAS having to service a set of mailboxes. We don't want that. We want to be able to allow any CAS to service any set of mailboxes in the architecture. So that's one of the paradigms that we shifted to with Exchange 2013. We also introduced other changes in this model. Fundamentally, what's the endpoint that we're trying to reach? The endpoint we're trying to reach is the mailbox. It's not a mailbox server. It's not a database. We're trying to get to the mailbox itself. All prior releases, we looked at the wrong scope. And that always introduced end user pain. Every time you moved the mailbox, the user had to get prompted to restart his Outlook client. So we've moved away from that in Exchange 2013 by focusing the RPC endpoint to be the mailbox GUID and a SMTP suffix for our multi-tenant type of scenarios. But this gets us to a much more reliable and stable connectivity model. We're utilizing HTTP straight through, and then we de-encapsulate that on the mailbox server and access the data. The other key thing with RPC HTTP is that RPC is a full duplex type of connection. It expects to both send and receive simultaneously. HTTP, on the other hand, is half duplex, which means that for every RPC connection, we have to establish two long-lived HTTP connections. We have an RPC data in, which is responsible for sending RPC, and then we have an RPC data out, which is responsible for receiving RPC. And we'll establish one or more RPC connections as needed. You'll have one for directory, you'll have multiple RPC connections for mail, and then for every other connection you make, whether that be public folder data, shared mailboxes, site mailboxes, calendars, delegates, etc., we'll spin up more long-lived connections as necessary to access that data. The important thing here is that we simply proxy that data through CAS to the mailbox server hosting the active copy for that particular mailbox. We then, in IIS, through the RPC proxy component, we de-encapsulate RPC, and we send that local RPC to the RPC client access service. And then that accesses the store to retrieve that data. Another way to look at this is that you have three layers. You have HTTP, you have the RPC protocol, and within the RPC protocol, you have the messaging API interface where all the remote operations are being passed between client and server for your data rendering. But we weren't done there. In Exchange 2013 SP1, we introduced a new connectivity paradigm, what we're referring to as MAPI HTTP. Now, why did we introduce this model? From a development perspective, it makes sense. We don't want to rely on RPC any longer. RPC is owned by the Windows Server team, and it's used by thousands of applications in the world. Probably tens of thousands of applications in the world. Anytime we want to innovate and improve RPC, we have this competition with, will we break some other application that's been in existence since Windows shipped? And so it makes it very hard for us to make improvements in RPC. So from a protocol development team, we're very interested in owning our own protocol stacks and ensuring that we can innovate them as necessary to improve end user experience. So this is the fundamental reason why we've introduced this new protocol known as MAPI HTTP. It removes the entire RPC intermediary components from both the client and the server from a connectivity perspective. It does require Service Pack 1 for Exchange 2013 and Outlook 2013, the most up-to-date Outlook 2013 bits, depending on how you're rolling out Office 2013, whether it's the MSI or the Office 365 subscription. The beauty, though, is that once you enable MAPI HTTP into your environment, Auto-Discover will be used to reconfigure the Outlook profile. The user doesn't have to get prompted either. We will continue to use RPC HTTP as the connectivity model until the user actually restarts his Outlook client, maybe due to a reboot, scheduled maintenance, shutting down the system at the end of the day, whatever. It becomes more natural for the user. Once they finally reboot their Outlook instance, we'll be utilizing the new interface, MAPI HTTP. I've already mentioned one of the reasons why we've done this. Well, what were the tangible results? First and foremost, time to connect. How long it takes us to reestablish a connection after failure. We evaluated all of our Microsoft user population in this scenario, all 90,000 plus our contingent staff in this study. And we found that with the MAPI HTTP protocol, 80% of our users now connect in 5 seconds or less after a connection failure. Compared to RPC HTTP, 80% of the users connect in 15 seconds or less. So a 10-second gain in reconnection right there just by removing RPC and utilizing this new protocol stack. But it doesn't end there. Hibernation is rather critical in the mobile world. We see that a lot now. Well, resuming from hibernation and reestablishing synchronization, 82% of the users with the MAPI HTTP protocol reestablish that synchronization within 30 seconds or less, compared to 77% in RPC HTTP. And then finally, the cold boot scenario. Starting up Outlook for the first time, how long it takes to actually establish that, see that connected to Exchange in that bottom right-hand corner. 73% of the users take 30 seconds or less. With RPC HTTP, that's 55% of the users take 30% or less. So a significant perf gain in that first synchronization once you boot up Outlook. That's the efficiency of this new protocol. The other benefit to this new protocol, one that we struggled with RPC for a vast number of years, is diagnostic information. We were very limited in what and how we could isolate and troubleshoot issues that occurred at the RPC layer. That's no longer the case with the MAPI HTTP protocol. We have extremely good instrumentation around diagnostic data that we can retrieve from the MAPI HTTP protocol. So now we can determine what issues are occurring and resolve them at a much faster pace. And last but not least, this finally gets us to a single or common authentication scheme across all the client protocols, because now we're leveraging HTTP as our client authentication protocol. No longer double authentication schemes, which is what we were doing with HTTP and RPC. So we'll be able to take advantage of that, and you'll hear more about that later on this week. So what does it look like from a connection standpoint? Well, first and foremost, we don't utilize long-lived connections anymore. So we have very short-lived connections that are requesting data and responding to those requests. How they respond to them is that we do maintain one long-lived connection for a hanging notification that tells the client that it needs to go talk to us. On the mailbox server role, you'll notice that the RPC client access service is no longer involved. No RPC. We're utilizing a new DLL, the HTTP MAPI handler DLL, that will take the MAPI data out of that HTTP session and go and query the store and access that data and render it as appropriately for the client. So another way to look at this is that we've removed a layer. We're now single wrapped for your enjoyment with MAPI HTTP. So client connectivity flow. Exchange 2007 is the special child in our coexistence environment. If I have an OA request, I'm going to redirect that request to the CAS 2007 infrastructure. Now, this request will be a single sign-on silent redirection event if source and target is forms-based authentication. If it's not forms-based authentication, then it will be a silent redirection event. If I need to proxy a request cross-site for OWA, I'm going to redirect to that Exchange 2007 infrastructure through the legacy namespace. It will proxy the request to the target Active Directory site to the target CAS 2007 infrastructure. If I'm Outlook Anywhere, I'm going to proxy the request through the CAS 2013 infrastructure. So the HTTP proxy component on CAS 2013 will simply proxy that request to CAS 2007 through, and then the RPC proxy component on CAS 2007 will de-encapsulate the RPC and send that request to the mailbox server. ActiveSync. Again, this is why I give the special designation for Exchange 2007, or the unique designation. ActiveSync does it differently than all the rest of the protocols with Exchange 2007. It will come in, it will authenticate on CAS 2013. We will then proxy the ActiveSync request to Mailbox 2013. Mailbox 2013 then has some special logic in it to do the service discovery, determine that that mailbox is 2007, and will then proxy that request to the internal URL of a CAS 2007 server in the mailbox server's site. (2010) much simpler. Effectively everything is proxied, whether it be ActiveSync, Outlook Anywhere, OWA. We simply proxy. CAS 2013 authenticates the request, route and proxies the request to a server fully qualified domain name of a CAS 2010 in the site in which that mailbox resides. That's it. Whether it be local or cross-site, we will simply proxy the request. There is one scenario where we won't proxy, and that is if on the OWA virtual directory in that target site, you have an external URL defined. In that scenario, we will issue a single sign-on silent redirection event, assuming source and target virtual directories have forms-based authentication enabled. Otherwise, it's simply a silent redirection event. That's the only time we'll redirect for Exchange 2010 connectivity. The rest is always a proxy event. So our end state. The first scenario we'll cover is a local request. I'm going to hit the load balancer. I'm going to be assigned to a CAS. CAS will authenticate me, do the service discovery, and proxy my request to the relevant protocol head on the mailbox server role that is hosting the active database copy for my mailbox. If I'm cross-site, same thing. I'll hit the load balancer, be assigned to a CAS. Now in this case, I have an external URL for OWA. Now, the only time we'll do an OWA redirect is when we have the target external URL does not match the source external URL. We got smart with this release, and we said, wait a minute, sometimes customers put the same external URL in both Active Directory sites because they're managing a namespace across both Active Directory sites. In prior releases, that involved a looping condition because we kept telling you to go back and forth. In this release, we're smart. If it's the same URL, we say, oh, let's proxy instead. If the URL is different than the source, we will issue an actual redirection, a single sign-on silent redirection, assuming forms-based authentication is enabled on source and target. Otherwise, if there's no external URL in OWA, for example, we will simply proxy. Now, it's important to understand that in Exchange 2013, we don't proxy to the CAS in the target Active Directory site. We proxy to the mailbox server in the target Active Directory site. We proxy to the server that hosts the active copy of the database. So while we'll have that CAS infrastructure in that target Active Directory site so that the users within that Active Directory site can access their data when the WAN's not available, it's not utilized for any sort of cross-site connectivity purposes. So let's talk about namespace planning and principles. We've done a lot of work in Exchange 2013 to decouple namespace activation from DAG activation in terms of a data center outage event, and making it such that the namespace can exist regardless of where your databases are activated. And we can route those requests to the active mailbox, to the mailbox server hosting the active copy. We've also done a lot of work to reduce the number of namespaces you need. I mean, for example, the first one that we've gotten rid of completely in Exchange 2013 is the RPC Client Access Array namespace. That namespace no longer exists in Exchange 2013 because our RPC endpoint is a GUID and not a fully qualified domain name. You also have the potential to get rid of unique namespaces in your data center pairs for your site resilient architecture. You no longer need to have namespace 1 for data center 1 and namespace 2 for data center 2. Oh, and an OA failback namespace for data center 1 and an OA failback namespace for data center 2. None of that's needed anymore in Exchange 2013. You can deploy in that model, but it's not necessary. And yes, you can still have regional namespaces where you can have a unique namespace for your North America data centers and a unique namespace for your European data centers. You can do that. We still recommend split DNS for your infrastructure, but there is one caveat there that I'll call out. It has to deal with Outlook Anywhere. Outlook, via AutoDiscover, generates an internal set configuration and an external configuration. If you do split DNS, you're saying that I'm going to use a single namespace regardless of whether my clients are internal or external. Well, with a single namespace with Outlook Anywhere, that external client is going to spin up, do a DNS record lookup, mail.contosa.com, attempt to connect to that namespace, find that it can connect. Well, if Outlook can connect to the namespace, it always attempts to use the internal configuration settings before it ever will utilize the external configuration settings. Now, it may not sound like a big deal, but where it becomes a big deal is your authentication scheme that you're deploying. If, for example, in your internal configuration, you want to leverage Kerberos or NTLM, but for your external, you're restricted to basic because you don't have a KDC proxy or some other advanced authentication solution on the internet, you're going to have a problem because your client that's now on the internet will attempt to connect, utilize the internal configuration settings, attempt to utilize Kerberos or NTLM, and fail to connect because he can't auth. So in this scenario, the only way to solve it is to have two unique namespaces for Outlook Anywhere. An Outlook Anywhere namespace that resolves on the internet and an Outlook Anywhere namespace that resolves on the internet. This doesn't impact users whatsoever, though, because the Outlook Anywhere namespace is fully resolved via AutoDiscover and configured based on AutoDiscover. So it's not something you have to worry about from an end-user education perspective, but it's something to keep in mind if you are deploying split DNS and having external Outlook clients. So there are, the way I look at namespace planning with Exchange 2013 is that we essentially have two types of namespace models. What I refer to as the bound model and what I refer to as the unbound model. What do I mean by bound model? Well, in a bound model, the users are associated or bound to a specific data center, meaning that there is a preference to have the users operate out of one of the data centers and only operate out of the other data center when there is a failure, sometimes catastrophic failures. But otherwise, I want those users constrained to one particular data center. This is very similar to the architecture that we recommended with Exchange 2010. You'll notice here that I have two namespaces, mail.contosa.com and mail2.contosa.com. Mail.contosa.com is associated with data center 1. Mail 2 is associated with data center 2. You'll also notice that I have two DAGs in this environment configured in an active-passive pair. I have the users that I want that have preference to data center 1. I have all their mailbox databases activated in DAG 1 in data center 1. And then all the users that are associated with data center 2 that have preference to operate out of data center 2, I have them in a separate DAG, DAG 2. And all their mailbox databases are activated in data center 2. And so I'm controlling connectivity in this manner. The users that are accessing data center 1 use the mail.contosa.com namespace, and the users that are accessing whose databases exist in data center 2 are utilizing mail 2's namespace. So if I have Sue here, she's going to connect to mail.contosa.com. We're going to get routed to the load balance array, assigned to a particular CAS. CAS is going to proxy that request to the mailbox server hosting my active copy. Or I could have Jane, whose mailbox is located in DAG 2, which is activated in data center 2, and she will hit the mail 2 VIP. What the bound model also means is that I am controlling my activation event. In the event of a failure, I have to move the relevant namespace, reconfigure that namespace to point to the data center that is still operational. So it's a controlled activation event as opposed to a seamless automatic activation event. Sure, it's scriptable and everything, just like we had in Exchange 2010, but it's very controlled. That's the bound model. As opposed to the unbound model. In the unbound model, essentially the way to look at this is that I don't have a preference for user connectivity. I don't care if my users connect through data center 2. I don't care if my users connect through data center 1. The requests will get to the correct endpoint regardless of user connectivity. Now, one path may be more favorable than another for a given user. There's nothing saying that each path is equal, but it does say that I just simply don't care how they connect, how they're routed. So Sue, in this case, will do a DNS lookup. Now, it could be as simple as multiple host records. I have VIP1, VIP2, both configured to mail.contosa.com. I could be deploying geographical DNS or some other solution that results in an equal distribution of load across these two VIPs. But I could choose either VIP. My connection could be routed to VIP1 or VIP2. If I hit VIP1, in this case, because Sue's mailbox is located on a mailbox server within Data Center 1, it's going to be a local proxy request. But I have an equal chance that her request could be routed through VIP2, and thus we're doing a cross-site proxy request to her mailbox server hosting the active copy. The other important thing in this scenario, when compared to the last scenario, is that in the last scenario, I was being very controlled, had multiple DAGs deployed, and controlling where databases were being activated so that I can control the user connectivity flow. In this scenario, I don't care. I have a DAG, and I have, hopefully, all the mailbox servers hosting active copies, distributing all my load across all the servers, thus being more efficient with my hardware. It also means that in this model, in the unbound model, that I don't have to do a controlled activation. I can have an automatic activation. My namespace is already automatic because it's resolving to both data centers automatically. And it will continue to do so. The HTTP clients are smart enough to know that if a record is unavailable, it will try again on the other record. So I don't even have to do any significant reconfiguration for namespace in the event that I have a failure. Now, as we'll talk in the high availability session later this week, we still want to do our data center activation steps in the event of a data center failure. I still want to shrink quorum and the like so that I can survive additional failure modes. But I have capability to have a seamless activation event in the event of failure. So now that we kind of understand the nuances of namespaces, we can talk about load balancing. As I've mentioned that, for a given protocol session, CAS is now maintaining a one-to-one relationship with the mailbox server, because all those sessions, regardless of which CAS they originate, all of those sessions end up at the same point, the mailbox server hosting the active copy. So we no longer need to worry about session affinity at the load balancing layer. It's unnecessary. It's complicated. It's CPU intensive. So we don't need it at the load balancing layer any longer. But we do have to think about other things with respect to load balancing. For example, health probes and configuration around our health infrastructure. We have managed availability on the Exchange side, taking protocols in and out of service based on the data we're collecting about those particular protocols. The last thing we want to do is have managed availability take a protocol out of service, and yet the load balancer thinks that protocol is still in the service. So we have a way to tie these two together so that the load balancer is aware of what managed availability is doing. And that's through a healthcheck.htm file, and I'll put file in air quotes because it actually doesn't exist on your servers. It's an in-memory calculation that managed availability is maintaining. And so you configure your health probes to check healthcheck.htm. If we get the correct response, a 200, 300 type of response, the load balancer knows that the protocol endpoint is up. If it doesn't get a response or gets a 500 type of error response, we know that the protocol is not healthy. And the load balancer then knows how to remove that from the load balance pool. So you want to be very prescriptive in ensuring you configure your load balancers to work with the healthcheck.htm in each virtual directory to make sure that you are aligning your load balancing health probes with managed availability. But as a result of moving away from session affinity at the load balancer and the nuances with health probes, it does impact our namespace planning. So if we do no session affinity and we just do a simple layer 4 load balancing solution where I simply know the rule that this particular protocol is applied to, I know my IP and port. That's all I know at layer 4. In that case, I have to make a decision, since I only have one rule on the load balancer, what protocol I'm going to check, the health check. The protocol you want to health check is the protocol that's most used in your environment. So for the majority of our enterprise customers, it would probably be the RPC endpoint, or in the future, the MAPI endpoint as you move to MAPI HTTP. But if you're maybe a university, your end users might be all hip and cool using web browsers, and so they'll be using OA. So for example, let's configure the health check for this particular rule for mail.contoso.com to evaluate the OA virtual directory. So I'll have a health check that's constantly pinging that healthcheck.htm to see if it's there. As long as it's being responsive, all my connectivity, whether I'm going to ECP, OA, EWS, OAB, RPC, etc., all of that will be fine. This particular server will be part of the load balancing pool. Now I do have another rule on my load balancer for the auto discover namespace. So it has its own health check as well. However, if this particular health check fails, then all the protocols on this particular CAS will be taken out of service. Because I have no way in this configuration with a single rule for mail.contoso.com and a single health check at layer 4 to know whether RPC is healthy versus OA. I don't know what my endpoint is. All I know is what I came in on and where I'm attempting to go, TCP 443. That's it. So that is a limitation with a layer 4 load balancing type of scheme. I have simplicity in my namespace model, but I only can achieve per server availability. So that brings us to layer 7 as a potential option. Now with layer 7, generally people think session affinity. Layer 7 doesn't necessarily mean you are doing session affinity. You don't have to have an SSL ID or a session cookie associated with this. At its simplest form, layer 7 is simply doing SSL decryption. I'm decrypting the connection coming in. I may be re-encrypting it at the end, or with SP1, I may just offload it altogether at the load balancer and do straight HTTP to CAS infrastructure. The key here is that once we get to layer 7 in this model, we can now do health checking per protocol. So I can check OA, I can check RPC, I can check OAB, etc. Which means that even though I have a single namespace, if OA fails, only OA is affected in this load balance pool. I still have connectivity. This CAS is still a member for RPC connectivity. This CAS was only removed from the OA load balancing pool. So now I have per protocol availability in this particular scenario. Finally, there's one other namespace option, load balancing configuration. And this is what we refer to as multiple namespaces at layer 4. So we take the deficiency that we had in layer 4 and we remove it. So we want to gain back per protocol availability. So in this scenario, I have a unique namespace per virtual directory. Now I know where I'm going. So I have individual rules for each protocol. So now I can do a health check for each individual rule at the load balancing layer. And I can remove protocols that are not healthy while still maintaining the other protocols in this particular CAS. So I get per protocol availability as a bonus in this model. The trade-offs obviously are that I have multiple namespaces, with the caveat that the only namespace that the user really ever notices is the OA namespace. The rest of the namespaces are handled via auto-discover. But I also do have to have more VIPs, and these namespaces do have to be on the certificate, which could be costly depending on your certificate provider. But it is an option. So the whole intent of what I just went through was to show that there is a great variety of different configuration options with load balancing. You can have a more simplistic approach with the layer 4, or you can have a more functional approach with the layer 7. And there are different positives and takeaways depending on which approach you go. Per protocol availability versus per server availability, the cost of doing SSL offloading versus not doing SSL offloading, the cost of multiple namespaces versus a single namespace, and the like. So you have different choices with respect to your load balancing architecture in Exchange 2013. So with that, let's talk about the preferred architecture. I'm going to be very prescriptive here. This is the way we want you to deploy Exchange 2013. This is the most tested configuration of Exchange 2013. This is extremely similar to what we deploy in Office 365. So if you want to be following on the path of the recommended approach, the best practices, or what term you want to use, this is the architecture you want to deploy. Anything else, and you're going into a supported but not recommended architecture. So it starts off with a namespace design. We recommend the unbound model. For a site-resilient data center pair, you have a single namespace per protocol deployed across both data centers, with a load balance configuration that is not leveraging session affinity, that equally assigns requests to either data center. Now, I put some examples up there around the namespaces because we say single namespace. Single namespace means a great many things. It could mean one namespace, mail.contoso.com, and that's used for HTTP, that's used for IMAP, that's used for POP, that's used for SMTP, etc. It could be per protocol. I have a unique namespace for all my HTTP clients. I have a unique namespace for IMAP clients. Kind of goes back to what we discussed with the load balancing configuration. Having if we're doing true layer 4, having unique namespace gives us per protocol of connectivity type of scenarios. But that's our namespace design. Our DAG design. How many of you stretch your Active Directory site across data centers? Don't do it. For one simple reason. The transport architecture that I talked about earlier. The ability for us to put the shadow copy in the other Active Directory site to gain site resilience for transport queuing. If you stretch your Active Directory site, you don't get that. We have no way to determine that the mailbox servers are located in Data Center 2 if you stretch the Active Directory site. So that's why we recommend separating the Active Directory site. Plus, there's the whole thing about we expect an Active Directory site to have 10 milliseconds or less network latency. Obviously, we recommend an unbound DAG model, where you're deploying your mailbox servers across your Active Directory sites, and each and every mailbox server is hosting active database copies. So you're dispersing your database copies across all your mailbox servers. How many copies? 4. 2 in each data center. One of those is going to be a lag database copy. That lag database copy is going to be configured at a minimum of 7 days replay lag time. And it will be configured to automatically play down in the event of a problem. What do I mean by automatic play down? In the past, the lag database copy was seen as a true point-in-time resiliency solution. Well, the way we look at the lag database copy today is more of a means to provide recovery in the event of a logical corruption, but more so to continue to act as a highly available copy if need be. And so we want it to be able to recover itself in the event of a page corruption event. We want to be able to play down the lag database copy in the event that you are running in a reduced number of highly available database copies. We want to play down the lag copy in the event that we detect capacity issues on the lag database copy. So it's more of a point-in-time backup for 90% of the time, highly available copy for the remainder of the time, is the way to look at the lag database copy. It also means that in this type of approach, you can deploy the lag database copy on JBOD and not have to worry about complicated storage approach of having your lag copy rated while the rest of your copies are on JBOD. Native data protection, leveraging single item recovery, in-place hold technologies, mailbox repair request, calendar repair assistant, and the like, to leverage the native features within Exchange to provide your recovery solutions, so that you don't have to go out of application for recovery and deal with the expense and the overhead associated with that. And for the first time, you're probably seeing this. We're not recommending 2 networks, a MAPI network and a replication network. 10 gigabit NICs and network infrastructure is on the horizon. It's being deployed fairly regularly as data centers upgrade. There is no need to dedicate a MAPI and a replication network in these type of environments. Plus, there's that scenario where you are logically breaking your MAPI and replication network up, but they actually are running on the same physical pipe. Doesn't really provide you the resiliency there that you're hoping for, so you might as well just combine them and be done. Simplicity is better is a common theme you'll see from the engineering team. I talked about earlier on how the unbound model can get you to an automatic activation event. How that's achieved is by deploying the witness server in a third data center that is connected to the data centers hosting your mailbox servers. This will provide you the means to automatically activate in the event that you have a failure event of your other data center. So we definitely recommend, if you have a third data center that is connected to the other 2 data centers, to deploy the witness server in that location so that you don't have to deal with a manual activation step. But like I said, you still want to run through the data center activation process to shrink the quorum so you can survive additional failure modes. And last but not least, increasing DAG size density before creating new DAGs. If you ask me, Ross, I want to deploy 2 4-member DAGs, or should I deploy 1 8-member DAG? I'm going to tell you hands down, deploy the 1 8-member DAG. Why? Because it's more resilient from a quorum perspective. You get better resiliency with a larger DAG. So increase the density of the DAG before you start breaking out smaller DAGs. Now you do have to balance that with your building block architecture, right? If you deploy an 8-member DAG and then suddenly you need to increase your size and you want to add more, that could really screw up your copy architecture. So you have to balance that approach. But you generally want to deploy larger DAGs as opposed to a bunch of smaller DAGs. This finally leads us to our server design. Multi-role servers. I know I stood on stage last year and said, or in 2012 and said multi-role servers. So I'm here to say it again. I don't want to see you deploying dedicated server roles. It's unnecessary. It's a waste of hardware. Combine the 2 roles, utilize the efficiency of that hardware that you're purchasing, and take advantage of an increased number of client access servers for a better resiliency in terms of your proxy, your intelligent proxy. Also, if it didn't sink in when I told you that you don't need 10,000 RPM disks or 15,000 RPM disks or solid state drives, just to reiterate it, 7,200 RPM disks are what we want you to deploy on. There's no need to deploy on any other type of disk. You don't need the I/O. You need the capacity. Large format disks. 4 terabytes today, 6 to 8 this year, 10 to 12 next year. That's what we want you to deploy on. Take advantage of the capacity that we have built into the system through multiple databases per volume. And naturally, we want you to deploy those 7,200 RPM disks in JBOD. If you're deploying 4 copies, you don't need 8 copies. You don't need RAID. You don't need the overhead and the expense of RAID. It's unnecessary. It's overcomplicated. We built the system to handle it from an application perspective. And how we handle it is with auto reseed. If a disk fails, the system automatically activates a hot spare and initiates the reseed of the databases that were affected so that you don't have to. The only thing you have to do at that point is to replace the disk and set it back up as a hot spare so that the system can reuse it again if it fails. It always goes without saying, if you're going to deploy on large capacity disks, you need to take advantage of them. So you need to deploy large mailboxes. You heard today that we're offering 50 gig mailboxes in Office 365. Our competitors also offer 50 gig mailboxes. Your personal accounts are minimum 50 gigs probably today. So it stands to reason that you shouldn't be trying to screw your users with small mailboxes anymore. Because users love to do what you tell them they can't do. Store their data where you don't want them to. Whether that be in PSTs or network shares or in public folders or in the dumpster or wherever they want to place it so that they can retain it despite you wanting them to delete it, they will find a way. And it's easier, instead of just combating them, to just give them what they want. Increase their productivity. Don't make them have to sit there and manage for an hour a day their 50 meg mailbox quota or 100 meg mailbox quota. Give them the gigabytes they need. I'll raise my hand. I have 19 gigabytes of data in my mailbox today. I don't ever sit there and delete anything. I don't ever have to worry about deleting anything. Records management does it all for me. It deletes what I don't need after a certain number of days or months or weeks. I have all types of rules configured, so I don't have to worry about it. I just get my email and go on my day. And I put a chart up here that kind of outlines what this would look like for your end users. Assuming 150 message profiles, 75 kilobyte average message size, just in 4 years, without deleting anything, that's 11.2 gigabytes. That's nothing with a 4 terabyte disk. Peanuts. And it allows you to get rid of PSTs. And hopefully those third-party atrocious stubbing solutions. Only one little golf clap? Come on! Some of you may say, but hey, this 11.2 gigabyte mailbox size is going to be like 30 gigabytes with Outlook 2010 OST's architecture. And I'd say yes, it'll be rather large on Outlook 2010. But Outlook 2013 is not the case. It's always brighter with the next release. Outlook 2013 has a significant number of compression enhancements to the OST so that 11.2 gig OST size will be significantly reduced. My 19 gig mailbox on Outlook 2013 is about 11 gigs, I believe. And that's after a year, 2 years of running it. So it hasn't ballooned like it normally does in Outlook 2010. But it gets better, because we now have a slider in Outlook 2013. So you can say, all right, I have my clients running on small solid-state drives. I really can't give them a 30 gig OST, because that'll chew up the majority of the disk space. So I'll just set a slider, 3 months, 6 months, 1 year, or my personal favorite, 2 years, all controlled via GPO, if need be, so that they only download the most relevant data. And when they're connected to their Exchange infrastructure, they're operating in hybrid mode, and they see their new data and their old data. And when they're offline, they only see the data, the most recent data in their OST. So you can control the OST size now with Outlook 2013. And that honestly introduces different scenarios for you. You may no longer need to deploy an archive mailbox with Exchange 2013 due to this nifty feature. You could have all your data deployed in a primary mailbox. Or you could offload a significant chunk of that old data to us in Office 365. We'll gladly host your archive data. So what does this look like from a preferred architecture perspective? Well, I decided to throw in the regional namespace model. I have a European set of data centers, and I have a North America data centers. So from a regional perspective, I'm operating in a bound namespace model. I want to control the users based on the region they're in. But within the region, I could care less where they connect. I'm in an unbound model. So Selena, in this case, her mailbox is located in North America, so she's going to utilize the northamerica.contosa.com namespace and hit either the Orange Data Center's VIPs to get access to her mailbox database. Or I could be Batman trying to find Catwoman and have my mailbox located in the European data center, and I'm going to hit either European VIP to access my mailbox and not the North America. Why? Because that WAN connection between North America and Europe for Contoso, in this case, is extremely costly. And it's cost prohibitive for me to send all my requests across the big pond. So I don't want to in this scenario. So I restrict that. But that's the type of architecture we can deploy with Exchange 2013. So in summary, we've introduced new building blocks that facilitate deployments at all scales, from whether you're hosting 100 mailboxes to whether you're hosting hundreds of millions of mailboxes in Office 365. We've introduced significant flexibility in terms of our high availability, namespace planning, and load balancing architectures. We've decoupled our namespace from our data center activation architectures, so you can now have an unbound namespace and distribute requests across both data centers. The key thing to remember is that all core Exchange functionality for a given mailbox is always serviced by the mailbox server's protocols that are hosting the active database copy. No other mailbox server will ever be involved from a protocol perspective in that regard. It's always the mailbox server that hosts the active copy. And finally, I want you to take advantage of large capacity 7200 RPM SAS drives. It's where we're headed in our technology. I've shown you what everything we've done from a storage and extensible storage engine perspective. We will continue to innovate on there. We will continue to drive down our I/O simply to make it more capacity efficient to stuff more mailboxes on these large capacity disks. so that you can have larger mailboxes. If it's 100 gig today, it's 200 gigs tomorrow. 400 gigabytes. A terabyte. Can you imagine? Terabyte mailboxes? Whew. Crazy. But simpler is better. That is the preferred architecture's approach. Simplify where appropriate. Deploy commodity hardware. Take advantage of the CPU and memory that's on that hardware by deploying multi-role boxes. And deploying a multiple copy architecture that leverages high availability and native data protection features to protect your data. And with that, I'll allow you to go to lunch.